Okay, good morning, Algebra 2. So we are going to move on from reciprocal functions, which is what we were graphing last week, to rational functions. So the difference between these two guys is that with a rational function, there is the opportunity to have a variable in the numerator as well as the denominator. Remember, with a reciprocal function, it was just like 1 over x or 5 over x, something like that. First off, let's just describe what a rational function looks like. And it's just something like this, where p of x and q of x, those guys are both polynomials. So that means we have polynomial p of x, could be something like maybe x plus 5. And then q of x could be another polynomial, maybe 2x minus 3. So the kicker is these guys are both polynomials, but q of x, because it's in the denominator, whatever that polynomial is, it just can't equal 0, right? We can't divide by 0. Okay, so here's the steps we're going to take to actually graph a rational function. Number 1, we're going to simplify the function. Okay? And number 2, we're going to find the x-intercepts by setting the numerator equal to 0. Number 3, we're going to find the vertical asymptotes by setting the denominator equal to 0. And then we're going to find the horizontal asymptote by using the highest exponent rule. Okay? So this is a little interesting, but I'll explain in more detail. So if the degree of our numerator is greater than the degree of our denominator, that's what p and q represent, our numerator and denominator. Okay, then we are going to have no horizontal asymptote. If the degree of our numerator is less than the degree of our denominator, then we're going to have an asymptote at y equals 0, which that's our x-axis. Okay? And if the degrees are equal, and remember the degree is just the highest exponent. So say we had x squared is the highest exponent up top in the numerator and x squared on the bottom. All we have to do is simplify down those two terms with the highest exponents. So I'm just going to take the leading coefficient of my numerator, p, and divide it by the leading coefficient of my denominator, q. And then our final step is to find any holes in the function. So we've never heard of holes, and what a hole actually is the point where there's just a break in our graph. And that'll sometimes happen when we have a situation where something in our numerator and our denominator can cancel. Right? So if we have a common factor between the numerator and denominator, what we're going to do is we're going to set that common factor equal to 0 and solve, right? And that'll give us the x-coordinate. To find the y-coordinate, all we have to do is just plug that guy back into our function, and it should tell us what the y-coordinate is going to be. Okay? So what I would highly suggest doing, if you haven't printed this out, is writing these steps down just so you know what to do each time. So let's just go ahead and jump in, and we're going to find a bunch of different pieces of information about these guys. So for number 1 here, we have x minus 4 over x plus 4. So first, we want to simplify the function. It looks like in this case we can't factor anything, so this is as simple as we're going to get. And number 2 is we're going to find the x-intercept or x-intercepts by setting the numerator equal to 0. So this is step 2 here, and we're going to take this x minus 4 and we're going to set it equal to 0. I'm going to put a 2 next to it just to say that's step 2. So I add 4 and I get x equals 4. So that means my x-intercept is going to be at 4 comma 0. Okay. Step 3 is find the vertical asymptotes by setting the denominator equal to 0. So for step 3, I can find my vertical asymptote. I'm just going to set my denominator equal to 0. That's x plus 4 equals 0. I solve it, and it looks like we're going to have a vertical asymptote at x equals negative 4. Okay, and then for our horizontal asymptote, we have to use this whole highest exponent rule situation, which remember we have 3 different scenarios that could play out. So what we're doing here is we're looking at the degree of each of our numerator and our denominator. The degree of this top guy is 1. It's just x to the first power. The degree of the bottom guy is also 1. So that's one of those situations where the degrees equal each other, degree our numerator is equal to the degree of our denominator. So we just take our leading coefficients, which is 1 and 1, and we divide them by each other, which ends up just giving us 1. So our horizontal asymptote is going to be at y equals 1. Okay, remember, to check for holes, we see if we have a common factor in our numerator and denominator, and that means just like something we can cancel, but in this case we can't cancel anything, so we don't have any holes. Right? And what I would do is I would use Desmos. If you have a graphing calculator, that's great as well, but I would actually plug this guy in. We can get a few pieces of information. We know our x-intercept is at 4, 0, so I can plot a point there. We know we have a vertical asymptote at x equals -4, so that's like a vertical line at -4, and we have a horizontal asymptote at y equals 1. Okay? And if you go ahead and you put this guy in your calculator, I'm going to do something like, remember, parentheses around these guys, so x minus 4 divided by x plus 4. And I graph it, and you'll notice it's kind of a little bit off our stage, so I'm going to go ahead and change my window a little bit. I'm going to just do zoom 6, which will give me the standard window, and there you go. That looks a little more like it. All right, so looks like my graph is going to go something like this, and another like that right there. All right. So when it comes to our final part, which is our domain and our range, okay, our domain is going to be affected by our vertical asymptote. So we know the only x value we're not hitting with our graph is that -4, which is where our vertical asymptote was. For our range, right, it's going to be the horizontal asymptote that affects this. So this is similar to what we learned about reciprocal functions. So y cannot equal 1, but it can equal anything else. All right, so let's check out a few more examples before you guys practice here. Okay, I'm going to go ahead and I'm going to jump to number 3. So for number 3, we had x squared minus 1 over x minus 1. So remember, the first thing we're going to do is we're going to simplify it down, and that means factor if possible. So I have x plus 1 times x minus 1 is going to be how we factor x squared minus 1. That's the difference of squares. Okay, so this guy's all simplified down here. And what I noticed right off the bat is x minus 1 and x minus 1 are on the top and the bottom. So this is what we're talking about when we're talking about holes. So what we can actually do is we can cancel them, but that means there's going to be a hole at x equals here. And actually, we're going to make it a point instead. So I'm going to do 1, comma, and then we're going to find the y value in just a sec. But the reason why I did 1 is because x minus 1, if I set that equal to 0 and solve, I get positive 1. So now my function just looks like this, x plus 1. Okay, so now let's go ahead and do all these other steps. First off, our x-intercept, remember we just take our numerator and we set it equal to 0. So that's our numerator is just x plus 1 now. We set that equal to 0 and we get -1 when we solve it, right? And then our vertical asymptotes, we look at our denominator, but we no longer have one. So that means we don't have a vertical asymptote here. And then when we're trying to do our horizontal asymptote, go back to your original function, x squared over x, right? And the degree of the numerator is 2, x squared, right? The degree of the denominator is 1. So that means our numerator has a greater greater degree than our denominator. So in that situation, we have no horizontal asymptote. Okay, and now let's deal with this hole as well. So we want to find the y value for that hole. All we got to do is just plug in 1 into our simplified function. So I plug 1 in, 1 plus 1 is 2. Okay, so that's where the hole is going to be, and I'll show you how to draw that in just a sec. Okay. And now in this case, when we're thinking about our domain and range, it might be tempting to think, oh man, there aren't any restrictions. X can equal whatever for the domain, y can equal whatever for the range. But that's not true. The hole is going to be a restriction. So x cannot equal +1, and y cannot equal +2. Okay, I just took them right from that hole. Okay, and when you go ahead and graph this guy, what you'll notice is it's going to end up looking something like this right here. It's just going to be a straight line. Okay? But the thing is, when we draw that straight line, we got to make sure that at 1, 2, right? We put an open circle like that. That's how we actually draw a hole in our graph. So that means at that point there is no value, right? Okay, so let's check out maybe two more before we get rolling here. So for number 4, we have x plus 5 over x squared plus 9x plus 20. So remember, the first thing you do is you go ahead and you simplify it down, which means factor as much as possible. This guy right here, I can break it up and think what multiplies to 20 and also combines to 9. And that's going to be positive 5 and positive 4. So I simplified it down a bit. And what I noticed right off the bat, I got some stuff that can cancel, x plus 5. So that tells me I have a hole with an x value of negative 5. Remember, we're going to set it equal to 0 to figure out where that x value is. And now let's go ahead and do some work here. Okay, so now our simplified version is 1 over x plus 4. Right? When this guy got canceled, the only thing left is just a 1. Right? So when we try to get our x-intercept and set our numerator equal to 0, we just have 1 equals 0. That's not going to happen. So that means we're not going to have an x-intercept. And that's definitely a possibility. Right? And then for our vertical asymptote, we go to our denominator, which is x plus 4. And we set that equal to 0. So it looks like we're going to have a vertical asymptote at negative 4. For our horizontal asymptote, right, we're going to go ahead and look back in our original function and look at the degrees. Up top, we have a degree of 1. Down below, we have a degree of 2. So that means our numerator has a degree that's less than our denominator. So that's this middle situation here, which tells us we're going to have a horizontal asymptote at y equals 0. Right? So now let's go ahead and determine what our hole's y value is going to be. All we have to do is plug in negative 5 into our function. So if I do that, I'm going to get 1 over negative 5 plus 4. That's 1 over negative 1, which is negative 1. So that's where our hole is specifically. So we got to remember a few things here. Right? When we're determining our domain, what x cannot equal, we're going to have our vertical asymptotes, which is negative 4, but then also our hole, which is negative 5. So x cannot equal negative 4 or negative 5. For our range, we're not going to be able to equal 0, and we're not going to be able to equal negative 1 either. I got the 0 from my horizontal asymptote, and I also have that negative 1 from our hole. So now I'm going to go ahead and graph this guy. I'm going to put in my calc as x plus 5 over x squared plus 9x plus 20. And you'll notice I get something that looks like this right here. And remember, I have vertical asymptote at negative 4, another one at y equals 0, and then I have a hole at negative 5, negative 1. So there's a little open circle at negative 5, negative 1. And if we look at our graph, remember, you can use Desmos if you don't have a graph calculator. It looks something like that right there. Okay. Let's try just one more. So number 6, and then we'll have you guys practice. So let's check out number 6. First thing we want to do is simplify everything down. So we have x cubed plus 3x squared over x squared plus 2x minus 3. And what we can do is we can factor a lot of this. I can pull an x squared out of that top and be left with x plus 3 over, and then down below I can factor this guy. It's going to be what multiplies to negative 3 and combines to positive 2. That's positive 3 and negative 1. So right off the bat, I've noticed x plus 3 and x plus 3 are going to cancel. So remember, that tells me the location of a hole. Because those guys canceled, they're just going to give me a hole. So I have x squared over x minus 1 is my simplified form of this guy. Right? So now let's jump into everything. First off, we have x-intercept. It looks like our x-intercept for this guy, right? Remember, the way we find it is we take our numerator and set it equal to 0. We're actually just going to get 0, right? If we put x squared equal to 0 and solve it, the square root of 0 is just 0. Our vertical asymptote is what we get when we set our denominator equal to 0. So x minus 1 equal to 0. This is our vertical asymptote we're finding. I add 1, and I get x equals 1. So there's my vertical asymptote. And then horizontal asymptote, remember, I go ahead and I look at my original. I have x cubed over x squared. The degree of my numerator is bigger than the degree of my denominator. So that's going to be this first scenario where we have no horizontal asymptote. All right, so let's go ahead and figure out what the whole is going to look like for our y value. So I'm going to put a -3 in. So that's going to be -3 squared over -3 minus 1. That's +9 over -4, right? So that's going to be -9 over 4. That's where my whole is going to be. And then when I'm checking out my domain, remember that's affected by my vertical asymptote, so x cannot equal 1. And when I'm checking out my, n-3, which is the whole there. And then for my range, the horizontal asymptote isn't there, but I know that I have that -9 over 4 that I can't equal from my whole. Okay, so let's go ahead and put this guy in our calc. Okay, I'm going to put my entire function in there, and the numerator is going to be in parentheses, as well as the denominator. Okay, so this one looks pretty interesting, you'll notice. Let's go ahead and graph our vertical asymptote at x equals 1. We don't have a horizontal asymptote. We know we have a whole at -3 and then -9 over 4. -9 over 4 is like a little over -2. So that's where our whole is going to be, something like that. And now let's graph it. It looks like we have something like that, and then another guy going like that right there. We got our function. Okay, so that's it for today. What I want you to do to practice is homework 7, numbers 1 through, let's try 1 through 6. All right, remember all those homeworks are available if you needed help, and I'm available from 11 to 1 Monday through Friday. See you guys.